Hey everyone, today we will be focusing on graphs today, particularly focusing on building a weighted graph, own header file, and without any further hesitation, let's get started. And now we are going to be focusing on creating a weighted graph. Now, prior to, what I will be doing is that we are going to be creating a new header file in this case, because in order to create a weighted graph is really a type of graph that has connections based on different edges that have a different value associated with such. And for us to be able to replicate the behavior, we're going to create a new header file just for us, one, not to just get fully accustomed with the C++ syntax, but to also create the necessary behavior for our weighted graph. So in doing so, be sure to create a header file. I'm going to call this weighted graph right here. Yeah, it should be good. So this is our new header file called weighted graph, and what I will be doing is that first thing we always do is that we're going to include our libraries. We're going to have our class over here, and we're going to start filling out the class accordingly just within what we have. So our necessary libraries that we will need are going to be the following. We will include iOS stream. We will include vector. We will include list. Include CMath. Include unordered map. Include utility, then include SS stream over here, and then we will be using namespace std. We're going to create a class called class weighted graph. And just like what we did with our graph printer, what we'll have a public instance. We're going to have void print graph, constant vector, indicator of list. Then we're going to pair with integers as well. So int, and this will put our adjacency list directly inside, so we can print out. We're going to have constant over here. We're going to output our graph adjacency list, like we have done so over here. And down. And then we're going to have a for loop. Int v is equal to 0 for our vertices. V is less than the adjacency list size. When doing so, our iterator will actually increase. We represent it as v. We're going to output each vector that we have as v, and then we're going to have an arrow indicated for the direction of the following graph. And yes, you can have different combinations of graphs as well that would highlight their nature, just for reference. And then we're going to have a for auto loop or auto it for iterator, and we'll have our adjacency list with a vector on the inside. We'll start at the beginning, and then while the iterator does not equal to the end of the adjacency list, we will increment our iterator accordingly, and we're going to output each parentheses here, right here for iterator first, here, iterator second. There we go. And this will be in the case for our following values that we will output for our weighted graph. Count and L. We'll have count and L. We're going to output our graph edges using ASCII and L, and render graph adjacency to be able to start. There we go. Then we're going to have a private class that we have that's going to render our graph. Private void render graph, constant vector list pair int. Yep, we've done so, and we'll have adjacency list as well. Constant will indicate for our radius, constant int radius equal 10, constant int diameter equal 2 times radius plus 1, and then we'll have a vector strings to indicate the graph lines with diameter string for our diameter times 2, indicate for here, and int size is going to indicate the adjacency list's size that we will use whenever we're looping through our given values. And then I'm going to have a map, unordered map with key and value pairs, so indicating the actual integer values of what has been connected as well for our positions whenever we are given a series of values for our graph as well over what is connected and such. We're going to loop through by using a for loop for int I is equal to 0. This is how we initialize. I is less than the size, and then we increment I in this direction, so that way we go directly from the beginning to the end. We're going to have an angle. It's a double right here, 2.0 times m underscore pi times I divided by size. And then we're going to have int x equal radius plus static cast int radius times the cosine of the angle. Then we'll have int y equal radius plus static cast int radius times the sine for a following angle. And then we'll have our positions indicate based on the x and y axis. Positions at our following area indicated by x and y. And for int v is equal to 0. V is less than the size, while we increment each vertex, each of the following vertices accordingly throughout our adjacency list. We're going to have auto positions x and y equal positions of v, graph lines y x times 2 equal 0, and graph lines for y x times 2 plus 1 equal 0 plus v, and then for int v is equal to 0, v is less than the size, incrementing v accordingly. Then we're going to have another for loop for auto indicating the weights of the following edge, and then adjacency v for each following vector that we have. We're going to draw the arrow, so we're going to be calling upon a ladder function that like we did before. Void draw arrow. Just keep that right there. Arrow, graph lines, positions for V, positions for W, indicating for our expected two different vertices that we have. So V represents one, the first vertex, W represents the other one over which one is connected, and then we're going to have weights as another parameter to understand the nature and relationship from such. Then we'll have another for loop indicating for constant auto and line, graph lines, count, line, and L. There we go. We're going to draw arrow as well. Void draw arrow vector. Pair. Int from pair int two, since we're going to be doing from n2, and with our weight as well in each constant over here. Int x1 is going to be equal from first, then y1 is going to be equal to from dot second. Int x2 equal to dot first, y2 equal to dot second. Int distance of x is going to be equal to the absolute value of x2 minus x1, with also respective distance of y of the absolute value between y2 minus y1. This is why we have accordingly. Let me just put the spaces here. Int s of x is going to be x1, determining exactly the relationships between each respective vertex's distance between the x-axis and y-axis. We're going to have s of x equal x of 1 less than x of 2, or 1 for an edge case. We'll do the same thing for y. Slope accordingly. So here we have the distance. Here we have this following slope that we would need, given the fact that we're going to need different distances between such. Y, yep. And then error is going to be distance of x minus distance of y, overall between the two at its exact point. And then while we are scanning through everything, indicating it's true, if x of 1 is equal to x of 2 and y of 1 is equal to y of 2 in the respective vertices and respective distances, we're going to break, and then we're going to have another distance calculated with e2 if e2 is greater than the y at a negative position. We're going to redeclare here error less than distance y, x1 plus equal s of x if e2 is less than d of x, error plus equal distance of x, y1 equal s of y if x1 doesn't equal x2 or y1 doesn't equal y2. We're going to have our respective graph lines with respect of y1 x1 times 2 equal with outputting this part. So we have our edge case over here. Sorry if I misspelled that. If. Alright. Graph lines y2 x2 times 2 equal this. Place weight. Graph lines from to weight. And now we will have this function, place weight, placing the weight. So void place weight vector. All we can do right over here, we can literally do the exact same thing that we did before, except for the difference is that we will be placing the weight directly inside of a following graph line as well. Indicate exactly the significance of the weight between each of the lines. And we will have a string of vector of strings for our graph lines, indicating as a parameter, and then we're going to pair integers from, and then pair int to int weight constant up here, like we did before, up there, and then we could just do this part like what we did before. X and Y accordingly. X, Y, X, Y. And then int m of x is equal to x1 plus x2 divided by 2. And we do the same thing for y. String stream ss. This is going to indicate and differentiate between our following line versus our weight. And then we're going to have string weight. Just like this is weight string, ss dot string up here, converting following integers into strings depending on where we're at. Then what I'm going to do is I'm going to have a for loop here. Int I is equal to 0, I is less than the weight, string dot size, increment I accordingly. And then we'll have graph lines m of y, m of x times 2 plus I equal weight string at a following index as well. There we go. Make sure to also add this at the end, clean up all the necessary stuff. So we have a function to place the weight, we have a function to draw the arrow, we already have a function to draw, to render the graph and its radius, width, diameter. This can also be applied for cyclical versus acyclical, and this is where we print the graph. So overall, we have 4 functions whenever we print out the graph, and whenever we render our graph, draw the arrow, then place the necessary weight as well. So now all we need to do, I'm going to head over to our main file. We always have an int main function whenever we are printing out stuff, and we're going to return 0. Oh, hang on. I meant to command B build. Okay, build succeeded. And now we will be focusing on building our weighted graph and focus on our necessary problems now. Hey everyone, thank you very much for taking time to watch this. If you found this video helpful, be sure and feel free to please like and subscribe. And if you have any other questions or suggestions, please put them in the comment section. And as always, take care. Cheers. Bye-bye.